All right, so you don't have a whole lot of writing to do because I wrote it all down for you. I wanted to save some time today. So I'm going to put the pretty notes up though. You have the black and white copy. So you've got a couple additional theorems today. Theorem 7.4, your triangle proportionality theorem. You see a picture here? Isn't this a popular picture of what we've been working with lately? Right? And couldn't we easily prove these, the small triangle here and the big triangle, the two overlapping triangles, similar by AA? Haven't we done a lot of that? Because now I'm telling you that these bases here, what do those arrows mean? That they're parallel. So this theorem says if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, that's this right here, the C and the D, or the B and the D, then it separates the sides into segments of proportional lengths. So you weren't allowed to do this before. Before you would have had to have CB is to CA, that whole side, as CD is to CE, that whole side. But now we can break it up into this piece is proportional to this piece, as this little piece BA is proportional to this piece. Or I can go in this direction. I can say that CB over BA is equal to CD over DE. And so I put an example of a proportion you could set up. This is just one example. There's 4 different examples you could set up. But note that they all deal with the side lengths here that have been cut into pieces, not BD and not AE. So that will become handy. That's only if you have parallel sides. Theorem 7.5 says if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. Isn't that the converse of this theorem right here? Aren't they saying exactly the same thing but in reverse? Okay. So then 7.6, let's see how that's different. A segment whose endpoints are the midpoints of two sides. So this is slightly different in the fact that LM is the midpoint of RS and L is the midpoint of TR. So it's almost like this is a median. Remember the median in the trapezoids where it had to be directly in the middle of the figure, only this isn't a trapezoid. Look what happens. So if the segment whose endpoints are the midpoints of two sides of a triangle, they're parallel to the third side of the triangle, and the length is half the length of the third side. So this becomes parallel to this, and this is equal to half of its parallel side TS. Isn't that similar to the median formula for a trapezoid? Only we're not having the sum of the bases because there's not another base up here. So learn that formula, highlight it with your highlighter. Then flip it over to the back, and I whited out a bunch of stuff for you. So the first example says in the figure CA is 15, so let's go ahead and write in what we know. So CA is 15, so that's from here all the way to here. CE is 3. Don't we immediately know what AE is? What's AE? 12. So we subtracted that out, right? So I immediately can conclude that that's 12. And then DA is 8. And BA is 10. From here to here. So what else do I know? DB is 2, right? Your job is to determine if ED is parallel to CB. If these are parallel, what do you know about these pieces here? What are they going to be to each other? Proportional. Okay? So you can set up whatever proportion you like. Here's, somebody give me one. Suggest one proportion that we could use. Be brave. There's lots of them. Nobody wants to ponder it. No. Well, let's start with the segments and then we'll fill them in. What if I said AE? So this segment from here to here, A to E, what could we say it's proportional to? Be real loud. AD. So you can go from here to here. So notice I'm going from top down. So A to D is equal to, so then what are you going to put over here? EC is proportional to DB. That's not the only one. Couldn't I take my proportion and turn it this way? Could I have a proportion that's that way, with obviously my fraction bar going through here? I could. Or I could have it going upside down, couldn't I? Or sideways. So long as your cross products are going to be this times this equals that times that. So plug in the values that you know. So AE is 12, AD is 8, EC is 3, and DB is 2. So all you have to do is either reduce 12 eighths to 3 halves and have 3 halves equals 3 halves, or you can show their cross products and cross multiply. Either way, it doesn't matter. What's 8 times 3? 24 equals, what's 12 times 2? 24. So, since the cross products are equal, the segments are proportional. Therefore, ED is parallel to CB. Just set it there. Thank you. Oh, Chase, there's one more. No, that's not you. Hang on. Pardon me for a moment. There it is. Take that one. Okay. So all I did was show that I had cross products. So you do have to have work to support your theory. Then look over here. So now I have a bunch of parallel lines, don't I? With 2 transversals running through them. If these lines connected up here, wouldn't I have a triangle? I'd have a triangle and a triangle and a triangle and a triangle. So it's just a very glorified picture of this. If I extended these lines out and had more parallel bases, that's all this picture is. All I have to do is set this side proportional to this side proportional to this side proportional to that side. So I know 8 and 6. So that's what I'm going to have on my left side of my proportion. And I'm going from left to right. So I'm going from left to right. So maintain a consistent pattern. So what are you going to put on the other side in the numerator? X plus 5 over, what are you going to put next to 6? Yeah, across from x plus 5 is x. So to make life easier, I would reduce. 2 goes in here 4 times, and 2 goes in here 3 times. So I end up, when I cross multiply, with 4 times x is 4x, 3 times x is 3x, and 3 times 5 is 15. Subtract your 3x from both sides. Don't you end up with x equals 15? So if x is 15, doesn't that mean that this is 15 and this is 15? And then what's this one? So this one becomes 20. So then if I have to find y, I'm still going to use 8 and 6 because I might have made a mistake here. But I'm still going to have to use that one right there. So hopefully I didn't make a mistake. So for my second proportion, 8 is to 6 as what is to what? Yep, 2y plus 6 is to the 15. So you cross multiply and solve that on your own. When you get an answer, share it with those around you. Share it with those around you. Talk, talk, talk. I know it's first period, but chat. And what'd you get? 2? 7? Did you distribute all the way? I happen to reduce this to 4/3. Makes my math a little easier. So I don't have to work with such big numbers. When I cross multiply, 3 times the 2y was the 6y, 3 times the 6 was the 18, and then 4 times 15 is 60. When you subtract 18, you get 42, and when you divide by 6, you get 7. Now, I could have set up totally different proportions. I could have set up 8 over x plus 5, couldn't I? Equals 6 over x. So I can go top down, top down. I could have had 8 over 2y plus 6, 6 over 15. This is a 1-to-1 proportion, isn't it? So what should this turn out to be? If this is 15 and that's 15, this is 20, what should that turn out to be? 20. And if you plug 7 in for y, what do you get? You do get 20. So sometimes there's a way that you can check yourself. All right, so flip that. Now you do this problem all by yourself. So in the figure below, you're told what CA is, and I wrote that in there for you. What CE is, what DA and BA are. You are to determine if ED is parallel to CB. So go ahead and do that on your own. You're welcome to phone a friend if you'd like, but just not on yourself. Just saying. So when you get a solution, talk about it with those around you. Remember, it's saying determine if they're parallel. Is the answer necessarily going to be yes? Nope. What'd you get? This is the cross products I set up. You might not have set up the same proportion. And your cross products might not say 48 and 12. It depends on what you chose or if you reduce that kind of thing. But would you agree that I could put AE over AD, which is what I did here, and CE over DB, right? Is that a true proportion or an agreeable proportion? And so I plugged in 8 over 6 and 2 over 6. When I did my cross products, I got 48 and 12. Are those equal? Nope. So what does that tell you about line ED and CB? They are not parallel. If the sides are not proportional, those pieces are not proportional, then your quote parallel sides are not going to be parallel. Megan?
Well, just like in general, are you not supposed to reduce that either? 'Cause I know
You could. You absolutely could. I just chose not to.
Okay, because like that's what I did, but I like reduced it and then I got 12.
Okay, so if I had reduced it, 2 goes in here 4 times, right? 2 goes in here 3 times. 2 goes in there once, and 2 goes in there 3 times, right? Do you see how they don't equal the same fraction?
Yeah.
And then my cross products here would be 12, and here would be 3, so they still don't equal.
So I still did it.
Correct. Yep. And did somebody set up a different proportion? Share it if you did. T? So she did 8 over 2. Can she do that? So she's going down and up, right? And then 6 over 6. Can she do that? Yes. And then look what her cross products are. 8 times 6 is 48. 2 times 6 is 12. Aren't hers the same as mine? So it's a good proportion. Well, it doesn't prove them parallel, but she set up the proportion correctly. So your answer should be, therefore, since the sides or pieces, we'll say sides, since the sides are not proportional, line ED is not parallel to line CB. And I drew the picture so they looked like they possibly could be parallel, right? They're going to do that to you too. Will somebody let probably Melissa in? I'm guessing. No, I'm wrong again today. Who gets to leave today? Let me see. The lucky winner is Tony. You have a ticket out the door. Did you know you were leaving? I hope everything's okay. All right, so this time in example 2, we have triangle DEF, and they've given you the vertices, and I plotted them for you, did I not? Okay, so the question is, and you're going to have to write the question in. The question is, question A, find the coordinates of G, the midpoint of DE, and H, the midpoint of FE. I was going to wipe this out, but that really wasn't their original problem, just so you know. So how do you find the midpoint? What's the formula? X sub 1 plus X sub 2 over 2, comma, Y sub 1 plus Y sub 2 over 2, right? And it's an ordered pair. So you go ahead and find those. Bless you. I had a little issue with my order pairs, but shouldn't you have gotten 4, 3, and 5, 5? And is that where the points are on the graph? So in this case, I would find my midpoints. You definitely want to graph them on your triangle to make sure that it appears that they really are cutting through the midpoint of those sides. So if these are the midpoints, what do you conclude about these pieces right here, these sides from FD to GH? If this is the midpoint. Look at the very front page. What does this say? Segments whose endpoints are the midpoints of two sides of a triangle is parallel to the third side of the triangle. So one thing that we conclude is that those third sides are parallel, right? The other thing that we can conclude is that the length that connects those midpoints is half the length of the third side. So here's question 2 for part B. Part B says, what two lines are parallel? What's your response? DF is parallel to GH based upon the previously stated theorem. Now they could have asked you to find the length of DF given GH, but you know, they're not going to ask you that in here because you could just use a distance formula to find that. Or they could ask you to show that this is half of this, and you'd have to find the distance of this with the distance formula, the distance of this with the distance formula, and show that this is half of that. So that's another way they could ask you that question. Flip it over, last page. Just two theorems and two corollaries. Corollary 7.1 says if 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. And that's what we saw in one of those previous examples. So here's your many parallel lines, two transversals cutting through them. And I've written here all kinds of proportions that you could have written. These are not all of them. I only wrote 3 of them. But this is proportional to this. This is to this. This piece, if we actually had a point here labeled, would have been proportional to this piece. So you can look at that. And then corollary 7.2 says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal, meaning going through those parallel lines. So these are essentially saying the same thing. Again, they're converses of each other. Your homework is out of the textbook, so I'm going to have you try that, and then we're going to work on our quiz.